Are you tired of dealing with the data inconsistencies and race conditions in your .NET applications? My name is Remik, and in today's video we'll dive deeply into the world of optimistic concurrency control in the framework core using concurrency tokens to prevent the conflicts and ensure the data integrity in your multi-user systems. Don't forget to hit the subscribe button to not miss any new videos related to .NET. Give me a like, write the comment, and now we're going straight into the topic. Let's start with the overview about the concurrency conflicts and why it's so important to detect those and also properly act when they occur to ensure that the data in your system will be consistent. Let's start with the bank account that has an initial balance of $1,000 and will have two transactions, transaction A and transaction B. Transaction A is the withdrawal, so it begins by reading this initial state, so $1,000, and it attempts to update the balance to $800. And also the transaction B, so the deposit, and it also reads the same value of the initial state of the balance, so $1,000, and it attempts to update the balance to $1,300. So also, as you see on the screen, we have the conflict. It will be detected, so both transactions are trying to update the same balance based on the initial value that they have read from the database, and if it will be allowed to proceed without the concurrency control, this would lead to the inconsistent state. And the solution to that problem would be to apply the proper concurrency control mechanism. So in this case, the system ensures that the one transaction completes before another one will begin. So in this case, the correct final balance will be 1,100 because the first transaction will subtract $200 from the balance and the second one will add $300 to it. So this whole diagram illustrates the importance of handling concurrent transactions in the databases. Without the proper management, data integrity could be compromised, leading to the incorrect balances in this bank account system, and we'll have unhappy bank customers. Alright guys, so as you see on the screen, already we have an existing API as a starting point to this video. Together with domain and persistence layers, I have installed all necessary Nugget packages related to Entity Framework Core for now. So as you see, I am configuring the demo DB context to use the SQL server and fetch the DB connection string directly from upsetting this JSON file, and then we'll be using this demo DB context just to fill in all necessary configuration related to the concurrency control. And now we can just dive deeply into creating sample entity that will be called bank account, and also the base entity where we will have the ID in this base entity and also the raw version that will be treated as the concurrency token. Let's start to create the first entity, and it will be called bankaccount.cs, and in here we'll have the three properties, so account number, balance, and the owner name. I will just create also an abstract class that will be called base entity, where we will have the specific ID and also the concurrency token, so the raw version as an byte array. So I'll just create base entity.cs, and it will be the abstract class. So we have to inherit from this class in the bank account, so base entity, and I will create two properties. So the first one will be the ID, and the second one will be the raw version as a byte array. So public byte array raw version. So now the question, what is actually this raw version? So the raw version is the data type in the SQL server that is automatically updated every time the row is modified. So it serves for us the mechanism for optimistic concurrency control, allowing you to detect whether the row has been changed or not since it was retrieved. So as you see on the screen, it will be in the later phase of this video, but I will just quickly show you that it will be automatically changed when the row will be modified. When I will just change this balance to, let's say, 30, and I will click this button to submit, as you see, it has been changed. So when you retrieve this row and the row version will not be the same as you retrieve that, then we'll receive the specific exception from Entity Framework Core, and then we can handle this case accordingly based on our needs. So this row version will be handled automatically by the database, and it will allow us to handle properly the optimistic concurrency control. And now the very important part, we have to give the instruction for the Entity Framework Core to set up properly this row version as the concurrency token, and also we'll need to set up the constraint for this decimal balance. So we have to go into the DemoDB context and override one method that is called onModelCreating. So now I will just write protected override onModelCreating. So I will just override it, and in here I will just set up model builder dot entity, and we will have to specify the type, so the bank account, and for sure we need to reference the project of the domain. Yes, of course, we would like to do that. And after that, we have to set the property of the row version, and we have to set up this as the row version, so is row version method. And after that, we'll use also the model builder and specify the same entity type, so bank account. And after that, I'll just set the property as the balance, and this balance will have the specific column type, has column type, and in here it will be the decimal that will look exactly like this. Now we have to also specify the DB set for those bank accounts to create the database table for that. So I'll just write public DB set bank account and bank accounts. Now there's the time to create an initial migration for our database. So I'll just write down in the concurrency control directory that it will be the dotnet ef migrations at, it will be called initial migration, and we have to specify where our API is located. So it will be the concurrency control.api and where our DB context is located. So concurrency API domain persistence. As we see, the database migration has been properly created for us. We have the one big statement to create the table that will be called bank accounts, and we have the specific type of the balance that we defined in our demo DB context, so in here, and also this row version, as you see, is the type of the byte array, but the row version is set to the true, it's not nullable, and the type in the database will be called as the row version. So whenever you create the new row or you update it, then this row version will be updated or generated by the database. And now the last statement in the terminal, so we have to execute the database update statement to apply this migration and create for us the new database that will be called concurrency control demo DB, as we have defined it in our DB connection string in the app settings JSON file. So now I'll just write .NET ef database update. We have to specify as before where our API is located, so concurrency control.api, and the same for our DB context, so in the persistence layer. So the persistence we have to use in here. So when I will just click enter, it will create for us the new database. And now I will create an abstraction for the bank account repository that we'll create in just a while, and it will be called iBank account repository. It will be the interface, of course, and in here we'll have two methods. The first one to create the bank account, and the last one to update the balance of this account based on the specific ID of this account. So as you see on the screen, we have two methods. The first one will just only for the demo purposes create for us the bank account for us to generate a couple of them and then update respectively in this video, and the main method that will focus on just to update the balance based on the ID, and will add or subtract the amount based on this ID from the balance of this bank account. Now I will create the directory in the persistence layer that will be called repositories, and in here I'll create the bank account repository and implement this interface that we have created before. So it will be called bank account repository, and we'll implement this bank account repository and of course all the methods as well. Now let's create the constructor for our bank account repository class, and we have to inject DemoDB context, and we'll introduce the read-only field in here, and I'll modify this method to be asynchronous. And to create the bank account, it will be the very simple statement. So await context bank accounts add async, and in here we'll just create the new bank account based on the account number and also the owner name. So account number will be the same as what we have in the parameter of the method, and owner name as well. Owner name, and at the end we have to await context and save changes async. And now the key point of this tutorial, so how to handle the DB update concurrency exceptions that will occur from Entity Framework Core in case of having concurrency conflicts. So in this update balance async method, we'll just simply fetch the bank account from the database based on this account ID, and now in the next line we'll update the balance of this bank account. So I will just type account balance just to update it based on this amount. Now we have to write the try catch block to wrap this save changes async method into the try and catch only the specific DB update concurrency exception that will be thrown in case of having the concurrency conflict. So it will be thrown automatically by Entity Framework Core. So we'll just add this DB update concurrency exception in here. We're gonna copy this line, but it will be inside of the try. And now we have to reload this entity because in a while we're gonna implement the mechanism to retry of this update balance async method just to reload this entity and try once again, and to assign this to 3 times based on the exponential backoff mechanism from the poly library. So now we have to reload this entity to be up to date. So exception entries, we're gonna select single and reload async. After that, we'll just write down to the console that the concurrency exception occurred, and then we'll throw once again this exception. And now to apply the retry mechanism from the poly, we have to install this specific Nugget package in our persistence layer. So I will just add poly in here, and I will add the latest version of it to this layer. So I'm gonna install this one. Once we have the poly installed in our project, we are ready to define the policy to handle this DB update concurrency exception and retry accordingly to our policy. But if you're new to the poly in dotnet, recently I have created the video about poly with all the details. It should be visible on the top of the screen as the link to this video, so check this out if you're new to the poly. But now we have to create the private read-only async retry policy that will be called retry policy, and in the constructor we'll create this policy. So retry policy will be equal to the policy from the poly library and will handle the db update concurrency exception. We'll use the wait and retry async. We'll use the 3 in this case as the retry count. And now retry attempt will be in this case time span from seconds, and we have to assign here the exponential backoff mechanism. So we'll use the math.power function and we'll pass this retry attempt in here. And once we have this retry policy available, we have to wrap this whole content of our method inside of this poly policy. So I will just create await retry policy, execute async with the async in here, and I will just take the whole content of this method that we have implemented previously, and I will put this in here. Now I'll create two requests. So the first one will be called create bank account.cs and it will be the record, and we have to take the account number and also the owner name. The second request will be to update bank account balance, and we'll take the account ID and also the decimal amount. In the meantime, I have created in the modules directory the bank account module just to serve for us the minimal API, and we'll have two endpoints. The first one to update the bank account balance. So we are taking from the body the request that we have created, and also we are taking the iBank account repository, and we are using this update balance async method in here, and the same will be very similarly to map post to have the post endpoint to create the new bank account. And in the program CS, we have to now add the builder.services.add scoped, and we have to add this iBank account repository and also its implementation. So bank account repository, and also I will add those endpoints. So app.add bank account endpoints in here. Alright guys, so as you see on the screen, we have finally the whole implementation of handling the concurrency conflicts. In the bank accounts table in the database, we have nothing for now. Now we'll just run our API, create one bank account, and then test our solution with the concurrency conflict that will simulate in this scenario. So when I will run the API, I'll create the new bank account and then we'll update its balance as well. We have two endpoints in the Swagger as we have discussed. So the first one, we'll try it out. The account number will be some random string, let's say, and the owner name will be my name, and I'll just execute. And we're gonna refresh. As we see, we have the first row in our database. So we have the ID that was generated by the database and also this row version. So we have the balance for now as 0.00, and now we'll update this bank account balance as well to check if our solution works or not. And now I will use this ID to update the bank account balance. So I will use this second endpoint. I will try it out. And as the account ID, I will pass this value from the database. The amount will be 20. So when I will execute, it should update the balance of this bank account. I will refresh. We see that now the balance is 20. And now we'll do the same thing. So we will add amount of 20 to our balance, but at the same time, someone will add as well the amount of 20 to the balance, and it will update this row before we'll call this save changes async methods. So now we'll check how our retry policy will work like in this case, and also how this row will be refreshed in case of having this exception. So now when I will add once again the amount of 20, and as you see, we have the bank account with the balance 20, and also we have to make sure, yeah, we have this row version like that. Now I will add to this balance 20, so it will be 40 in this case, and I'll submit it. As you see, the row version has been changed, and this means that this row version will not be consistent to this one that we have over there, so it's something different, and this db update concurrency exception will be thrown. So as we see, we received this db update concurrency exception from entity.conf core that it was expected to affect one row, but actually it didn't affect anything in this case. So now when I will click resume, you see that the retry policy attempted to update this balance once again, and now we see that this row version is different and the balance is 40. So in this case, we'll add to this balance amount of 20, and once it refreshed this entry, so it reloaded this asynchronously, we have the randomly fetched from the database account, and we have added this amount, and as we see, also this row version was as follows, and when we will refresh it, the row version has been changed by our operation, by our Swagger endpoint, and this balance has been also changed appropriately. And now to summarize, so the row version as the column in the database will allow us to handle the optimistic concurrency control. So once the row will be updated, this row version automatically will be also updated, and this will invoke, in this case, the db update concurrency exception. And we have a couple of the options in here to, for instance, return this exception to the caller and decide what the caller will do in this case, or maybe to retry, as I have done this with the usage of the poly policy. If you haven't subscribed my channel yet, then please hit the subscribe button down below to not miss any new videos related to .NET, React, Angular, Docker and Kubernetes. Give me a like, write a comment, and see you in the next one.